Let us get started by opening Solidworks first. When you open Solidworks for the first time, you must accept the license agreement to use the software. Now that the software is up and running, go to File and choose New. This window allows you to choose 3 types of documents or templates to start working with. If the screen you're watching this video in was the product you wanted to design, you would model the On/Off button in Part Environment, the same with the frame or any other single-piece component. Then you would assemble all the pieces together in the assembly environment, where you would prepare a 3D model of the screen with all its pieces. You would then use the drawing environment to create 2D manufacturing drawings of everything you had designed. These designs would be printed on papers to be used in fabrication shops. Most of the times we start with modeling a part first. So, go ahead and select its button, and then click OK. This is the Solidworks user interface. I'll go through each section and explain its uses. You can also find useful information in Solidworks help documents. But first, we need to define the unit system. Click on this button, and from the list select mmgs, which stands for millimeter gram second. This is the unit system we'll be using throughout this course. These settings apply to all dimensions we enter for all entities. That means when you enter number 10 for a linear dimension, Solidworks will use the millimeter as a default unit unless you specify a different one for that dimension. In the user interface, we have Menu Bar. The menu bar contains a set of the most frequently used tool buttons from the standard toolbar, the Solidworks menus, the Solidworks search, and the flyout menu of help options. The menus are visible when you move the mouse over or click on Solidworks logo. Use this pin to keep them visible. By clicking the down arrow next to a tool button, you can expand it to display a flyout menu with additional functions. Toolbars. These assist you in performing specific design tasks, such as rotating the model or moving it around the screen. You have heads-up view toolbars here, which is very handy and provides quick access to the most used tools such as section cut or zoom and fit. Command Manager. This is probably the most important toolbar. Based on the environment you're using, it provides access to almost everything you can do in that environment. Basically, you use this toolbar to edit your parts, assemblies, and drawings. Configuration Manager. It is used to create, select, and view multiple configurations of your parts and assemblies in a document. We'll get to configurations later. Property Manager. It is used to set properties and other options for many Solidworks commands. When you run a command, its properties are set in here. For instance, the height of an extrude is a property of that extrude. Feature Manager Filter. It lets you search for specific features of parts and components of assemblies. Every feature you add to your models is listed here in the Feature Manager design tree. Currently, we have not created anything, so there's no features to show except the 3 main planes and the Cartesian coordinate vectors, also known as origin in Solidworks. This is the part we are editing, and it should have a default name like Part 1, unless you saved it with a different name. Status bar. It gives you information about the function you are performing. It gives the coordinates of your cursor, for example, or the unit system you are using. On top, you have Solidworks Search that lets you search in documentation, forums, or even 3D models. If you forgot how to find a specific command, you can come here and look for it. For example, if you ever wondered where the circle command is situated in the command manager, you can use the search bar to find it. Make sure the commands are selected to be searched in. Type circle here and click on this eye icon. Solidworks moves the cursor where the command is and points to it with a red arrow. You can use Solidworks Web Help to read more about each command. Make sure you use Solidworks Web Help and Solidworks Help are selected. Type User Interface Overview in the search bar and press Enter. This is the online help documents. From the list, choose this link. It might not be the second one for you. And here you have the help document about the user interface. Click on the task pane link to see what its uses and subsections are. That was it for this lesson. You'll create your first Solidworks model in the next video. There is no doubt that Dassault Systems has done a good job of developing a user-friendly CAD application. It's very easy to design with Solidworks. There are many powerful applications out there, but few are as easy to use. In this video, we will create your first model together. Use the new icon to create a new part document. Click on the front pane and select Sketch. In the Sketch tab, expand the straight slot and select the last item from the list. Hover your cursor over the origin point. When you saw that yellow symbol, click and move to left. Click again when R is about 15 millimeters. Now move the cursor clockwise to create an arc, like so, and then click again to place the arc on screen. Adjust the width of the slot by moving your cursor away from the arc, and then click to finish the slot. On the left, enter 15 for the radius and 10 for the width. Go to the Features tab and select the Extruded Boss Base icon. Type 5 mm for the depth, and click on the green check mark. Click on this face, and in the flyout toolbar that appears, select the sketch. Then click on Text in the Sketch toolbar. Select this edge and then click in the toolbox and type Hello World. You can adjust the text position with these buttons. When done with positioning the text, click on the green check mark. Then go to the Features tab and select the Extruded Boss Base again. Enter 1 for the depth. Press Enter on your keyboard and then click on the OK button. Right-click on the first feature in the design tree and expand the Appearance button. Click on the first item from the list to colorize your model. Pick a color and then click the OK button. Do the same for the other feature and pick another color for it. Congratulations! You just created your first 3D model in Solidworks. Make sure you save this file. Choose an appropriate name for it and click on the Save button. In the next lecture, I'll explain the tools and object we worked with in this video. When you launch Solidworks, go to File and click on New Icon. In this window, choose Part and then click on the OK button. Now you are in Part Editing environment. To create and then edit a part in SolidWorks, we need to draw its base sketch first. Every 3D model in this software is based on a sketch, and just like the way it works in the real world with pen and paper, every sketch needs to be drawn on a plane too. Without computers, we would draw on a piece of paper. If not a paper, a table, or even a wall would do. In SolidWorks, the same concept applies to sketches. Except for 3D sketches, we should always define the plane we want to draw the sketch on. Although very useful, the simplest sketches are points or dots and lines. Go ahead and initiate a sketch on any plane you like. Choose a plane from the design tree and select this button from the flyout menu, which starts a sketch on that plane. Another way of doing it is that you go to the Sketch tab and select the same command from there, and then select the plane. Notice the coordinate vectors, based on the plane you choose. This is either the XY, YZ, or XZ system. A point is shown with an asterisk. To create one, select it from the Sketch tab. Click to place 5 points on your screen. They can be deleted with the Delete button on your keyboard. When you select sketches, their type and other parameters such as coordinates are shown in the Property Manager on the left. As I move my mouse, these dotted lines tell me that the cursor is horizontally or vertically aligned with the other points. So, if I place my point right here, these 2 points should have the same x coordinates. The coordinates are demonstrated in the status bar. After placing the point, I can still drag it around. Notice that your cursor changed when you selected Point from the Sketch tab. This shows that you're drawing something, and if you click on your screen, a drawing will initiate. To revert cursor to mode, press Escape on your keyboard. In the next video, we'll use these points to create lines. So, make sure your file is saved on your computer. There are 3 types of lines in SOLIDWORKS 2017: line, center line, and midpoint line. You cannot use center lines to create 3D models. They're used for marking up your sketches and applying relations between entities. We know that a line is defined by 2 points, right? Well, that is exactly how a line is defined in SOLIDWORKS. Right-click on the sketch name in the design tree and select Edit Sketch. To draw a line, either press L or click on it in the Sketch tab. Click once to place the first point, and click twice to place the second point of the line. If you click and drag, no further line will initiate. But if you click and release your mouse button every time, another line starts immediately after. Try to make a closed polygon by connecting a few lines together. After you return to your starting point, no new line will start. Try other types of lines. Center line behaves exactly like line, but midpoint line is slightly different. You can use box selection and delete button to delete a few components together. If you're still in line command, Solidworks keeps drawing lines wherever you click. Press the escape button on your keyboard to exit the command. In the next video, we will connect these points together with lines, and I will talk about relations between sketches. Using the click and release method, connect all the points together. If your final polygon looks like this, or this, drag the points so that you come up with roughly the same shape as my polygon. This shade means that this polygon is now closed. It's ready to make 3D models of. We can apply relations between sketch entities. This is different from giving them dimensions. We'll get to dimensioning the sketches, but for now, I want to show you what these green symbols are. There are a few of them. This type here is called coincident, which means that two entities are attached together. In this case, the points we created, which are shown with asterisks, with the endpoints of the line. That is why when you drag the points, the lines go with them and vice versa. If you hover your mouse over any of the relations, you'll get a tooltip that shows what the relation is and apply it on which entities. Now click on the coincidence symbol and delete it. As you can see, the point is detached from the line and can be moved around. You can snap it back to its place. The yellow coincidence symbol means the point will have that relation applied when snapped to this location. When you select on one of the lines, you can see in the Property Manager tab that there is an Add Relation section. Currently, only 3 relations make sense for this line, so Solidworks has automatically filtered the rest. The Fix relation, as its name suggests, fixes the sketch on place. Both its dimensions and its positions are fixed as is, and it won't change unless you unfixed it. Vertical makes this line aligned with y-axis in this plane. If you choose both vertical and horizontal for the same line, Solidworks asks you, how can a line be both vertical and horizontal? So, delete one of the relations, if you applied both. If you select a few sketch entities together by holding Ctrl key down, then you can apply relations on all of them. For instance, if you selected all the lines, you're given a wider range of relations applicable to those. Go ahead and choose equal, so they are all equal in length. You can make lines collinear, and parallel too, but they would be of no use in this example. Now apply a horizontal relation for these 2 points, a horizontal relation on this line, and a vertical relation on these 2. Applying horizontal or vertical relations on points makes them aligned to X or Y axis of the plane you are drawing your sketches on. As you can see, although we have not given any dimension to the sketch, but its shape is always the same, we specify the size of the sketch, and that is the subject of the next lesson. In the following videos, we'll focus on status of the sketches. There are 3 modes for a sketch in Solidworks: underdefined, fully defined, and overdefined. Imagine that I had a plane on which I wanted to draw a rectangle. The plane would have an origin point with x and y vectors. To draw a rectangle, I had to specify its position. It could be here, or maybe here. Unless I specify the exact position, the application doesn't know where to create the sketch. So that is the first thing to consider. Both x and y coordinates of this point should be specified. Another thing is whether this line is horizontal or inclined. Maybe the angle is something else. Maybe it is like this. Until I clarify the exact dimensions, the geometry will not be fully defined, so the orientation should be specified. Next is the size of the rectangle itself. Is the rectangle this size or bigger? So, the 3 things that we need to be defined are the orientation of the lines in relation to these vectors, the position of the rectangle on the plane, and the size of the rectangle. The lengths of this side and this side. After that, I could have a fully defined black rectangle in Solidworks. You can dimension your sketches with the Smart Dimension command. Since all these lines have equal lengths, you just need to define the size for one of them and the rest will follow. To select the Smart Dimension command, hold down your right mouse button and move your cursor up, or you can select it from the Sketch menu. Click on one of the lines and click again to place the dimension. In the Modify window that appears, enter 100 for the length. These values are in millimeters. You can change their units by typing IN for inches, cm for centimeters, m for meters, and so on. You can change the default units in status bar. These two buttons on the right side increase or decrease the size by 10. The dial at the bottom does the same. You have a fair bit of options to adjust dimensions with. Click the OK button to set the dimensions. You don't need more than a few dimensions and relations to define a sketch. Anything more than required would overly define that sketch. That's why SolidWorks throws errors when you add dimensions to other lines. Remember that we set all these lines equal. Click OK to exit the error message. The second dimension is still there, but it's grayed out and is for information only. It is driven by other dimensions and relations. If you change the black 100 to 150, the second dimension follows. You cannot modify the driven dimensions. Now that we've defined the size and orientation of this sketch, we need to specify its position so it doesn't move around. We talked about overdefined sketches in previous lesson. In this lesson, we'll discuss about other modes of a sketch. We can see in the status bar that the sketch is underdefined. That means there are required parameter left to define. I'll explain it momentarily. SolidWorks has a few ways to show you that a sketch is underdefined. A blue color for the sketch itself, the underdefined keyword in the status bar, and a minus sign in parentheses besides the sketch name in the feature design tree. Although you can't change the size of the sketch, you can change its position. That is why it is still underdefined. To fix that, grab this point and snap it to the original in the center of the plane. This way you can apply a coincident relation between the origin and this corner. Now the sketch is fixed and nothing changes when you drag its entities. The color changed to black to indicate this, and the status of the sketch is fully defined in the status bar. There might be cases where a sketch is overdefined, which is not a good thing. We can get away with blue underdefined sketches, but overly defined sketches need to be dealt with before moving on to next stages. To see how it happens, we will deliberately make this sketch overdefined. Go ahead and apply another dimension on any line you like. But this time in the error message that appears, make the dimension the driving one. Now we have two driving dimensions on two lines that are equal. Why should there be two dimensions? SolidWorks asks. In the status bar, you're reminded that the sketch is overdefined and that you need to fix it. Select the second dimension and delete it to make everything normal again.